Perfect. So thank you very much. So let's start it. The title of my presentation is Graphene Revolution in Construction, Enhancing Concrete Properties and Durability. What is graphene? Graphene, like diamond and graphite, is a carbon-based material. However, it distinguishes itself by being two-dimensional, consisting of carbon atoms arranged in an hexagonal pattern with just one atom thickness. For reference, a millimeter of graphite contains about 3 million graphene layers. Nevertheless, the term graphene is specially used when referring to an extremely small quantity of carbon layers, such as a monolayer graphene, that is the most difficult graphene to obtain, bilayer graphene, the few layers graphene, that is up to 5 layers, and the multi-layer graphene, that is between 1 and less than 10 layers. If this limit is exceeded, it is more appropriately classified as graphite. The production of graphene can be costly and complex due to various factors, including the need for specialized techniques to exfoliate and stabilize graphene layers. High-quality graphene synthesis at a large scales remain a significant challenge for its entry into the market in products beyond the prototype design phase, requiring controlled processes, sophisticated equipment, and qualified personnel. This can increase costs compared to other more conventional materials. How many types of graphene exist? There are 2 general types of graphene. Graphene and graphene oxide are also called GO, and their characteristics are directly related to the production method and process used. Graphene materials are as diverse as the available production methods. This diversity is one of the main reasons why many reported results are not always reproducible. Graphene primarily consists of interlinked hydrophobic and conductive carbon atoms. On the other hand, graphene oxide, in addition to carbon atoms, contains numerous oxygen and hydrogen molecules anchored to its surface, forming functional groups that give it an hydrophilic and insulator character. Graphene oxide has found more applications due to its relatively easier production and its water-soluble structure, making it more manageable. The isolation of graphene is not so far above. No, it was the Nobel Prize awarded to Gain and Novoselov in 2010 after the success in isolating graphene in 2004 and discovering its extraordinary properties, not only recognized their outstanding work in graphene research, but also propelled research and development of this revolutionary material worldwide, leading to numerous advancements in the last decade. Graphene has earned the moniker all-in-one material, and that's because of its multi-properties. Graphene has a large surface area. 1 gram can cover 2,630 square meters. That's equally to a football field, depending on its characteristics. This allows the material to self-cooling capabilities and extensive interaction sites. It is also self-repairing. If one of its sheets loses atoms, neighboring atoms interact and reduce the size of the gap. This ability is responsible for the increased duration or durability of materials made with graphene. The hardness of graphene is superior to that of a diamond and approximately 200 times stronger than steel at an equal thickness. It is also rigid. It's capable of withstanding significant stress without deforming. Its Jones modulus is 1,100 gigapascals, allowing for reversible elongations of up to 10% and bending of up to 20% without suffering damage. Therefore, materials with graphene are less likely to break and are more durable. Graphene can act as an insulator or a semiconductor or conductor with even 10 times greater conductivity than copper or aluminum. In the case of processors, graphene can boost electrical frequencies to enhance information exchange speed. The material is resistant to both ionizing or non-ionizing radiation, making it valuable for reducing material degradation exposed to various environments. Graphene is an excellent thermal conductor because electrons move freely and at a high speed across the surface. It allows it to dissipate heat and withstand intense electric currents without heating up. Also, graphene is very dense and impermeable, even to the penetration of the smallest molecules, such as helium. It has shown significant promise in medicine, facilitating drug transport, tissue engineering for bone or skin regeneration, and designing prosthetic joints or dental materials due to its biocompatibility and excellent antimicrobial capacity. Beyond medical applications, graphene is being utilized for antimicrobial protection in various sectors, including healthcare, food, sports, hospitality, education, among others. The antimicrobial mechanism of graphene materials consists of 3 lines of defenses against microorganisms and fungus. First, it generates a physical barrier. The arrangement and electron density of its layers create a winding and repulsive path for the passage of particles. It also has oxidative stress that alters the respiratory chain of microorganisms or extracts their electrons until inactivating them. And it can generate a membrane damage. Its nanolayers alter the structure of the microorganism, preventing its adhesion. So its protection is different from other kind of products that include products that kill the organisms with chemical products. Well, nowadays, especially after these 10 years, there have been in the market a multiple industrial applications. Despite graphene's numerous properties, its real impact lies in its ability to transfer these properties to other materials to design compounds with new or enhanced characteristics. This property transfer occurs when graphene materials interact with molecules of other compounds, forming more ordered, compact, and robust architecture. Graphene materials are not miraculous. The success of a new development depends on numerous factors such as the selection of the type of graphene material, the production method, as well as the required characterization to make it possible to transfer its multiple properties to the material that is going to receive the enhancement. The identification of the correct variables are one of the most important challenges that industries nowadays must resolve to succeed in the use of graphene materials. Energía Graphene is our company, and we are a pioneer nanotechnology company established in Latin America. We are focused on graphene materials research, production, and industrial application development. Our approach centers on creating market-ready applications involving the production and functionalization of graphene materials to meet the specific needs of each project. Encourage the establishment of strategic partnerships with other companies to expand the use of graphene in various applications of an industry, this has been our main role in the last 10 years. And we are one of the few graphene companies globally with multiple commercialized products that goes from concrete additives, microfibers, coatings, and master batches. And well, let's start talking about concrete. What challenges does the cement industry face? Globally, several development and initiatives are underway to improve concrete properties and reduce its environmental impact. These efforts converge on key objectives, such as reducing carbon footprint, energy consumption, decreasing water usage, and promoting material recycling. The constant search for technologies and materials to enhance concrete performance and reduce its carbon footprint has become a critical goal. Nanotechnology provides a valuable tool for achieving this, as concrete is predominantly composed of nano-sized crystals of calcium silicate hydrates, also called CSH, with an average size of 10 nanometers that is responsible for its mechanical strength. Therefore, modifying the cement structure at the nanoscale brings significant benefits at the finished concrete product. Then, after saying this, what use graphene oxide in construction materials? Graphene materials offer significant potential to revolutionize the construction industry. This industry is the third largest source of CO2 emissions, and the global challenge for 2030 is to reduce these emissions by at least 16%. Recent studies estimate that the addition of graphene oxide will reduce just 5% of the cement in the concrete mix. Its impact on global warming will decrease by 21%. Graphene oxide has significant potential to promote the development of more sustainable solutions. Its ability to disperse in water and its affinity with cement nanoparticles make it particularly interesting, as it can improve mechanical properties and durability while reducing the number of resources needed and decreasing the environmental footprint of structures. This represents a significant step toward building a more ecological and energy efficient future. Then, how does graphene oxide improve building materials? The benefits of graphene oxide in cement-based structures originate from the iteration process. This is because GO acts as a platform that provides a numerous nuclei or anchor points for the growth of greater quantity of CSH crystals, which are highly important for their role in setting, hardening, strength, and stability of cement. In addition, GO acts as a nano reservoir of water, promoting hydration and workability of the mixes. In some cases, it can even reduce the water-cement ratio. How does the new GO-CSH link benefit the properties of cement-based structures? Well, let me tell you about an additive that we developed in 2018. We introduced to the market a concrete additive with graphene oxide as part of the Graphenergy construction product line. This additive improves the microstructure of cement conglomerates. It's a water-based additive and does not contain additional chemicals apart from active compound of GO, which, when naturally added to the concrete mix, provide multiple improvements with a single application. The aim of this presentation is to show you the diverse array of representative trials conducted to demonstrate the benefits that graphene oxide provide to concrete. One of the benefits that it can be observed is increase in mechanical strength. And then The numerous anchoring points offered by graphene oxide for the growth of CSH crystals and nanodeposits of water enhance the hydration of the cement paste. This phenomenon results in a higher quantity of CSH crystals anchored on the graphene oxide sheets, which in turn increases the density of the cement paste, reduces the size and or the number of pores, consequently creates a more compact material. Having a more compact microstructure also leads to a mechanical stronger structure against comprehensive or tensile stresses. This means that the concrete will be stronger and capable of supporting additional loads. Graph energy construction increases comprehensive strength in the range of 5 to 30%. It also enhances tensile strength between 11 and 24%. It increases the elastic modulus between 4 and 12% and improves abrasion resistance between 10 and 12. As I just told you, there is a range of the results that are obtained, and this range is due to the numerous variables that concrete designs can have. It also increases impermeability and corrosion and brings protection against corrosion. Concrete durability is significantly affected by its ability to resist water penetration and other liquids. Graphene oxide, in addition to increasing concrete density, acts as an effective barrier against the infiltration of water molecules through capillarity pores in concrete. This improves material impermeability and makes it less prone to water or aggressive ions absorption. This enhances protection against corrosion, particularly for common metal reinforcements in concrete, ultimately extending its lifespan. Graphene construction shows results that improves water impermeability up to 80% and reduce chloride ion permeability by 20 to 60%. It also provides higher electrical resistivity to concrete. The interaction between graphene oxide and CSH increases electrical resistivity in cement-based structures, meaning it helps to reduce the movements of charges caused by lower porosity and moisture content in the material. This is not only due to what graphene oxide triggers in the cement, but also because graphene oxide is well known for its insulating property. Therefore, concrete is less susceptible to corrosion that can affect reinforced or steel fiber reinforced concrete. All of this translates similarly to a stronger and more durable concrete or a longer service life. Graphene construction increases concrete resistivity between 15 and 60%. In other words, it helps concrete to be less porous, contains less moisture, and contribute to corrosion protection. It also works as a setting accelerator. GO acts as a catalyst in the hydration reaction of cement and promotes workability and accelerates drying and setting. And this is especially useful in the construction industry, allowing higher strengths at early ages, and in prefabricated structures, graphene energy construction can accelerate the setting time from 30 to 40%. As I told you before, graphene also promotes heat dispersion, and this characteristic is also observed when it is mixed with concrete. Heat dispersion is another aspect in which graphene oxide brings significant advantages in construction, with its initial effects occurring during the hydration process. It helps control temperature differences that arise and subsequently translate into a noteworthy reduction in thermal cracks. in hardened concrete, the presence of GO improves the thermal conductivity of the material. This means that heat spreads more efficiently through the concrete, resulting in a better heat distribution in the structure. GO increases the fire resistance of concrete. This means that the structure can withstand higher temperatures for a longer period without losing its integrity. This benefit is crucial for the safety of buildings, especially in fire situations. Thanks to the heat dispersion properties of GO, significant cost reductions can be experienced in air conditioning equipment usage. A structure with GO can maintain more stable and comfortable temperatures, leading to energy and air conditioning cost savings. In fact, a reduction of up to 3 Celsius degrees in indoor temperatures have been observed in constructions using GO additives, benefiting both the environment and the economy of property owners. And it also provides antimicrobial protection. Under normal conditions, microorganisms are capable of penetrating structures through the surface porosities. Once housed and in the presence of rich organic matter, such as wastewater, microbial consortia tend to corrode and increase the porosity of surface, accelerating their deterioration. The interaction between GO and CSH improves the compactness of concrete, reducing moisture permeability. This limits water penetration and thus creates a less favorable environment for the growth of microorganisms, which is especially important in structures exposed to humid environments. The presence of GO limits the conditions necessary for anchoring and reproduction of microorganisms responsible for the microbiologically induced corrosion, or MIC. In organic-rich environments, such as wastewater, microbial consortia can increase the porosity of structures, accelerating their deterioration. Well, after reviewing all these benefits, in conclusion, we can say that the incorporation of graphene oxide additives enhances several concrete properties, extending its lifespan, while potentially reducing cement usage and energy consumption. These benefits contribute to the reduction in the carbon footprint associated with concrete production and usage. Well, thank you very much. And I don't know if you have any other questions.